Okay, example 5 is an inverse trigonometric equation. And what I want you to notice here is that we have an inverse cosine of x, and it does say solve. Anytime you see the word solve in any kind of math class, it means to get x equals everything else. That's what it means. All right. How you go about doing that is kind of determined on where x is and what it's with. The fact that x is the argument of an inverse trigonometric function tells me job 1, get that thing solved first. In other words, get this thing all by itself equal to everything else. So if I move the sine inverse of 3/5 over there, I get cosine negative 1x equals pi minus sine negative 1 of 3/5. If I continue on this theme, if cosine inverse of x equals that stuff, I know you guys just wrote this down. I'm going to do, oops, that's not what I want to do. I'm going to slide this over just a little bit. All right. What we learned on Friday was that if I did the cosine of the inverse cosine of x, what do I get? X. As long as x is within our domain, right? X had to be between -1 and 1. All right. So let's start there. I can say right now that x has to be between -1 and 1. This x right here, I can't do this otherwise, right? It says inverse cosine of 2, the answer, it's not possible. So I basically have a domain on this problem. There's no answers other than between -1 and 1 possible on this. So if I get x equals 3, it's wrong. If I get x equals 2/3, that's fine, it can be 2/3. If I get x equals pi over 7, yeah, that's less than 1. About a half-ish. All right? So what I'm telling you, though, is that if I cosine an inverse cosine, I get x. And that's what I'm looking for, is x equals, right? So what I'm going to do is I'm going to cosine both sides. I'm going to cosine this side, and I'm going to cosine this side. Because again, that's the rule. I need to get x equals, that's how you get an inverse cosine function out of the problem. You have to cosine both sides. Now this side is just a single object, this is multiple objects, so it's got to be this binomial structure. All right, this becomes x on this side. And again, because I chose to do that, I am stuck with x has to be between these numbers. If I get that, fine. If I get x equals 2, empty set. Throw it out and call it the empty set. This is basically what the last problem was. I've got cosine of an angle minus an angle. This one's pi, which is our friendly neighborhood pi, right? It's always the same pi that's always there. Cosine is equal to -1, sine 0, and all that stuff. But inverse sine of 3/5 is our first quadrant angle, having an opposite side measuring 3 and a hypotenuse measuring 5. So alpha here, there's 3/5 sine, 3, 4, 5 right triangle to get the third side of the triangle. And if I change this problem into cosine of pi minus inverse sine of 3/5 into cosine of pi minus alpha, same problem, because again, I've invented alpha to represent this thing here. Get in the habit of doing that, because almost all these problems where you're having to do some trig function of these things, drawing the triangle is going to make it very easy to do that. Now, what I see is cosine of a difference, and according to number 33 on our useful trig sheet, cosine of a difference is cosine of both angles. And then change the sign, and then sine of both angles. What's the sine of pi? Remember what sine of pi is? Sine of pi is 0. So 0 times whatever this is just cancels out, because that equals 0. Sine of pi happens to equal 3/5, or sorry, sine of alpha over here is 3/5, but that's irrelevant because whatever multiplied by 0 is 0. So that's gone. Cosine of pi is equal to? -1, okay? -1. Cosine of alpha, I can look here, 4/5. So x is going to equal -4/5, which is between -1 and 1, which is a legal answer, so there you go. So trigonometric equations, that's basically what you do. Get the trig expression, inverse trigonometric equations even. Get the trig expression isolated, take that trig function to both sides, and then apply whichever sum difference identity is required over here. If it's secant, cosecant, or cotangent, it's 1 over one of the ones you have. Just put 1 over that, and then kind of create the structure that you need, and that you can handle that. That's how that works.